We're almost finished with section 1.4. We've already talked about factoring and a quadratic formula and the square root property. And now the last method for solving a quadratic equation is called completing the square. And we'll get to that in just a minute. But before we do, we should go back and work one more problem by the factoring method. So here is example 4, x squared plus 10x plus 25 equals 0. And if you remember, when we see the coefficient on x squared is 1, then we say that we're just looking for two numbers that are going to multiply to 25. And those same two numbers need to add up to the coefficient on x, this 10 right here. And so the two numbers, probably you can see pretty quickly, are going to be 5 and 5. And so you can take that and you can write your factors as x plus 5 times x plus 5. Normally we don't write the factors like that. Normally, since the two factors are the same, we just write it as x plus 5 squared is equal to 0. And then if we're going to go on and finish the problem, then we're going to set the factors equal to 0. So if we, the first factor is x plus 5 is equal to 0. And so if we subtract 5 from both sides, we have x equals negative 5. And of course, there's another factor of x plus 5, right? So there's one factor of x plus 5 set equal to 0. You could set the other factor of x plus 5 equal to 0. Of course, you would still get the same answer. So in this problem, there's only one answer, and that answer is negative 5. When we solve quadratic equations, usually what we've seen is we get two solutions, but it's possible to only get one. And so that's an important point that we can make with this example. And there's another important point that we can make with this example. What we see here is this trinomial, these three terms together make something called a perfect square trinomial. PST for short, perfect square trinomial. And so trinomial, because there are three terms, and then perfect square means that this is the perfect square, is the square of x plus 5. When you square x plus 5, you get x squared plus 10x plus 25. So this is a special kind of trinomial because when you factor it, the two factors are exactly the same. And in fact, when we go on to the next example, we'll be looking for a perfect square trinomial. So let's go ahead and do that. So we're going to talk about the method of completing the square. And the method is a little bit involved. And so I've actually taken the time to write out 5 steps for us to follow. You'll want to practice this a few times and make sure you know this method before the first exam. So let's just read through the directions one step at a time and try to apply them to our quadratic equation that we're given here in example 5. So let's start with an equation of the form ax squared plus bx plus c equals 0, and we have that. And so then the first step is to check the coefficient on x squared. Right? That's called a in the general form. If a is not equal to 1, then we divide. But in our example, a is equal to 1, so that makes life a little bit easier. And so we can say that step 1 is already taken care of. Okay. Step 2, rewrite the equation so that the x squared term and the x term appear on one side of the equal sign, and the constant is alone on the other side. So the constant here is this 4, and so we're going to subtract 4 from both sides. so that we get x squared minus 6x on one side, and we get minus 4 on the other side. And so then we have finished the second step. Now what we're going to do in step 3 and 4 is we're going to create a, I guess step 3 creates a perfect square trinomial, and then step 4 we're going to factor that perfect square trinomial. So a special step here, it says find the coefficient on the x term. Here it is, it's negative 6. And take half of this number and then square the result. So half of negative 6 is negative 3, and then square that. Negative 3 squared is 9. So that's that process may seem a little bit mysterious here as we get started, but we'll see in just a minute how effective it is for getting what we want. In particular, what we want is a perfect square trinomial. So square the result to get 9. Whatever you get, add it to both sides of the equation. So we're going to add 9 to both sides of the equation. We'll have x squared minus 6x plus 9 is equal to negative 4 plus 9. And again, just for emphasis, this 9, this calculation in green gave us the 9 that we add to both sides. Okay, now what we have here on the left is a perfect square trinomial. When we factor it, the two factors will be exactly the same. Can you see what they are? You can actually go through the factoring. You can say m times n is equal to 9, and m plus n is equal to negative 6. And so the two numbers must both be negative 3. And so when we factor, we get x minus 3 times x minus 3, or x minus 3 squared. On the other side, we can simplify and just get 5. So we factored the perfect square trinomial here on the left, and we combine like terms over here on the right. We're on to step 5. And we're going to go ahead and use the square root property to finish solving the problem. And so that's what we just learned in the previous video. We learned that if we have something squared on one side and a constant on the other side, that we can get rid of the square. We can drop the square away and just have x minus 3 on the left if we just do two things on the right. Start with a plus or minus, and then a square root on top of that constant 5. Just one more step now to finish. We can add 3 to both sides, and we have our answer. X is equal to 3 plus the square root of 5, or 3 minus the square root of 5. And of course, we could put that in set notation as well. We're done. Okay, that's a little bit tricky. That's not an easy problem to do. So let's go ahead and do one more example like this. So actually, this is a problem from the homework. We'll call it example 6. And we're going to start out with negative 4x squared plus 8x is equal to 7. And we're going to solve by completing the square. Okay, do you remember the steps? The very first step says if a is not equal to 1, divide both sides of the equation by a. So a is the coefficient on x squared. It's negative 4 this time. We don't want it to be negative 4. We want it to be 1. And so the way that we do that, the way that we get it, what we want, is we divide by 4. divide by -4 on both sides. And then we have -4x squared over -4 just gets us x squared. And then 8x divided by -4 gives us -2x. And then on the other side of the equation, we have -7/4. Okay, that was step 1. Step 2 was to rewrite the equation so the x squared and the x term are on one side and the constant is on the other side. Well, we already have that, so that's good. Step 3 now is to create the perfect square trinomial. Do you remember how to do it? The key is to look at this number right here, the coefficient on x, and we want to take that number, we want to take half of it. In this case, half of -2 is -1, and then we want to square that -1 and get +1. And so that +1 is what we need to add to both sides of the equation. So we'll have x squared minus 2x plus 1 is equal to -7/4 plus 1. Now we have a perfect square trinomial. That's step 4. We have the perfect square trinomial. We're ready to factor it. And you can see pretty quickly that the factors are both x minus 1. So we have x minus 1 squared is equal to, on the other side, we can add the fractions. This is 1 is the same as 4 over 4, so we'll have -3 over 4 when we add those together. And maybe now you have a better sense of just how neat this process is. What we're doing is we're taking any old quadratic like this one that we're given at the beginning of the problem, and we're turning it into something where we can use the square root property. Right? Square root property only applies in a very special case where you have this variable expression on the left that's getting squared and a constant on the right. And now what we found out is that we can actually go through and take any old quadratic and turn it into this special case for the square root property. So that's the procedure we've just gone through. Now we're ready in step 5 to use the square root property to finish the problem. So let's go ahead and take the square root property. That will drop the square off of the left side, and then on the right side, 2 consequences, a plus or minus, and then a square root on top of that constant on the right. And just a couple more steps to go. Let's go ahead and add the 1 over to the other side, and let's get x equals 1 plus or minus. And then we need to simplify this square root of -3/4. And so let's do it like this. Let's take the negative up into the numerator, and let's leave square root of 4 down below. And then we can do a couple more things here. Let's see, in the numerator, the negative comes out as an I. And in the denominator, square root of 4 is just 2. So what we wind up with is 1 plus or minus √3 over 2 times I. Well, that's a nice problem. Okay, let's go ahead and stop there. And I have one more video for this section where I'll try to go through and explain where the quadratic formula comes from.